hydrogen atom is excited from ground state to another state with the principal quantum number is equal to 4, then the number of spectral lines in the emission spectra will be. So we have to find the number of spectral lines from quantum number n is equal to 4. Number of lines will be n into n minus 1 upon 2, which is equal to 6. So option D is the correct answer. The series limit for Balmer series of hydrogen spectra is A 3800, B 4200, C 3646, D 4000. The last line in any series is called series limit. Series limit for Balmer series is 3646 angstrom unit. This is produced by solving lambda is equal to RH 1 upon n1 square minus 1 upon n2 square. Here n1 is taken as 2 and n2 is taken as infinity. On solving we get this. This is the last line of Balmer series, option C. The ionization energy of hydrogen atom is minus 13.6 eV. The energy required to excite the electron in hydrogen atom from ground state to the first excited state is, Avogadro number is given. We know that energy is equal to minus 13.6 upon n square. So for hydrogen atom we take from ground state to the first excited state minus 13.6 divided by 4 is equal to minus 3.4 eV. We know that energy required for excitation is change in energy is equal to E2 minus E1, which is equal to minus 3.4 minus into minus 13.6, which is 10.2 eV. Therefore energy required for excitation of electron of per atom is equal to 10.2 upon Avogadro's number, which is equal to 1.69 into 10 raised to minus 23 joules. So option B is the correct answer. The frequency of wave of light is 12 into 10 raised to 14 per second. The number of wave associated with this light is, frequency is given as mu is equal to 12 into 10 raised to 14 per second, and the velocity of the light is c is equal to 3 into 10 raised to 8 meter per second or 10 raised to 10 centimeter per second. We know that the wave number is nu upon c, which we can write as 12 into 10 raised to 14 per second divided by 3 into 10 raised to 10 centimeter per second. So on solving this we get 4 into 10 raised to 4 per centimeter. So option D is the correct answer. The Bohr orbit radius for the hydrogen atom is approximately 0.530 angstrom. The radius of the first excited state orbit is, first excited state means n is equal to 2. Here r is equal to r0 into 2 square, which is equal to 0.53 into 4. On solving this we get 2.12 angstrom. So the radius of the first excited state is 2.12 angstrom units. Total number of valence electrons in 4.2 gram of nitronium N3 minus ion is, where Na is Avogadro number. A 1.6 Na, B 3.2 Na, C 2.1 Na, D 4.2 Na. We know that 42 grams of nitronium ion have 16 Na valence electrons. 4.2 gram of N3 minus will have 16 Na divided by 42 into 4.2, which is equal to 1.6 Na. So option A is the correct answer. The energy of the electron in the first orbit of He plus, that is helium ion, is this much. The energy of the electron in the first orbit of hydrogen would be He plus ion energy is equal to energy of hydrogen ion Z square minus 871.6 into 10 raised to minus 20, which is given, equal to hydrogen ion energy into 4. So energy of hydrogen ion in first orbit is minus 2.17, sorry, 217.9 into 10 raised to minus 20 joules. Option C is the correct answer. The frequency of one of the lines of Paschen series of hydrogen is this much. The quantum number of N2 which produces this transition is, we know that formula for frequency is 1 upon lambda, which is equal to RH 1 upon N1 square minus 1 upon N2 square. So 1 upon lambda is equal to RH 1 upon 3 square minus 1 upon N2 square. From here, solving, N2 is equal to 5 for Paschen series. So option B will be the correct answer, which produces a transition of this much hertz. Select the correct statement. A. Cyanamide ion is isoelectronic with carbon dioxide and has the same linear structure. B. Mg2C3 reacts with water to form propyne. C. CaC2 calcium carbide has NaCl type lattice. D. All of the above. So you have to choose which of the statement is correct. So the cyanide ion C double bond N minus, C double bond N minus, and carbon dioxide, thus both has isoelectronic and isostructural. So option A is correct. In option B, Mg2C3 reacts with water to form CH3C double triple bond CH propyne plus magnesium hydroxide. And statement third, Ca2 plus C2 minus has NaCl type lattice. Hence all the statements are correct. Option D is the correct answer. The number of nodal planes in a px is A1, B2, C3, D0. The number of nodal planes are present in a px orbital is 1, or number of nodal plane is equal to L for px orbital. We can show this by the structure. This is the nodal plane for x. Similarly, there will be for y and z. So p orbital has 3 suborbits: px, py, pz. So option A is the correct answer. The ratio of energy of photon of 2000 angstrom wavelength radiation of that of the 4000 angstrom radiation is. So if to find the ratio of energy, we know that energy is equal to h nu, which is equal to hc upon lambda. So we know that energy is inversely proportional to wavelength. Therefore, E1 upon E2 is equal to lambda 2 upon lambda 1. In this statement, we have to see that both the other constant values. So lambda 2 is 4000 and lambda 1 is 2000. Ratio is 2:1. So option D is the correct answer. The increasing order, lowest first, from the values of E by m charge by mass for electron, proton, neutron and alpha particle is E by m for neutron is equal to 0 upon 1 as the charge is neutral of neutron. For alpha particle it is 2 by 4 which is equal to 0.5. For proton is equal to 1 upon 1 which is equal to 1, and for electron it is equal to 1 upon 1 by 1837. This is the mass, so it is equal to 1837. So option D will be the correct answer. The value of Planck constant is 6.63 into 10 raised to minus 34 joules. The velocity of the light is 3 into 10 raised to 8 meter per second. Which value is closest to the wavelength in nanometer of a quantum of light with frequency 8 into 10 raised to 15 per second? We know that lambda is equal to c upon nu. So 3 into 10 raised to 8 divided by 8 into 10 raised to 15. So on solving this we get 3.75 into 10 raised to minus 8. So 3.75 into 10 raised to minus 8 into 10 raised to 9 nanometers. So we get 3.75 or into 10 raised to 1 nanometer. We can write this as 4 into 10 raised to 1 nanometer approximate value. So option D is the correct answer. The energy of an electron in first Bohr orbit of hydrogen atom is minus 13.6 eV. The possible energy values of the excited state of electron in Bohr orbit to hydrogen atom is, the value of energy in excited state is 13.6 eV upon n square minus 13.6 upon 4 is equal to minus 3.4 eV, in which n is equal to 2, 3, 4, etc. So option A is the correct answer. Nucleus of an atom can be assumed to be spherical. The radius of the nucleus of mass number A is given by 1.25 into 10 raised to minus 13 into 10 into A raised to 1 by 3 centimeter. Radius of the atom is 1 angstrom. If the mass number is 64, then the fraction of the atomic volume that is occupied by the nucleus is. So we have to find the fraction of atomic volume. Radius of the nucleus is 1.25 into 10 raised to minus 13 into A 1 by 3 centimeter. We can write this as 1.25 into 10 raised to minus 13 into 64 1 by 3. On solving this we get 5 into 10 raised to minus 13 centimeter. So the radius of atom is 1 angstrom, which is equal to 10 raised to minus 8 centimeter. So volume of nucleus upon volume of atom is equal to 4 by 3 pi r cube, which is 5 into 10 raised to minus 13 cube radius of nucleus, divided by 4 by 3 pi r cube radius of atom, which is 10 raised to minus 8 cube. On solving this we get fraction as 1.25 into 10 raised to minus 13 centimeter cube. So option D is the correct answer. In a Bohr's model of atom, when an electron jumps from n1 to n3, how much energy will be emitted or absorbed? We have to find this in ergs. According to Bohr's model, delta is equal to E1 minus E3. So 2.179 into 10 raised to minus 11 minus 2.179 into 10 raised to 11 upon 9, E1 minus E3. 8 by 9 into 2.179 into 10 raised to minus 11 on solving the above equation. On solving this, we get 1.91 into 10 raised to minus 11, which we can write it as 0.191 into 10 raised to minus 10 erg. Since the electron is going from N1 to N3, hence energy is absorbed. It is going from lower orbital to higher orbital. So option B is the correct answer. Atom consists of proton, neutron and electron. If the mass of the neutron and electron are made half and 2 times respectively to their actual mass, then the atomic mass of carbon 12 is no change by doubling mass of electron. However, by reducing mass of neutron by half, atomic mass becomes 6 plus 3 instead of 6 plus 6, thus reduced by 25%. So option D is the correct answer. Which of the following atom and ion are isoelectronic, that is have the same number of electron with the neon atom? So we have to find the isoelectronic with neon atom. Fluoride have same number of electrons with the neon atom. Fluorine has 9 and it has 1 extra electron to become fluoride, so it has 10 electrons, and neon is a stable noble gas which has 10 electrons. So option A is the correct answer. Which of the following set of quantum number is correct for an electron of 4f orbital? So we have to find the quantum numbers for 4f orbital, where n is equal to 4. So L is equal to 3, because 0, 1, 2, 3, the azimuthal quantum number S, P, D, F. So M becomes plus 3, plus 2, plus 1, 0, minus 3, minus 2, minus 1. And the spin quantum number, or S, will be plus half. So of this, option A is the correct answer. The Schrodinger wave equation of hydrogen atom is this, where A0 is Bohr's radius. If the radial node is 2s, be at R0, then find the radius in terms of A0. So we know that the Schrodinger wave equation is psi 2s is equal to 1 upon 4 root 2 pi 1 upon A0 raised to 3 by 2 into 2 minus R0 upon A0 e raised to R upon A0. This is uncertainty principle. At node, psi 2s square is equal to 0. This is at node. Then 2 minus R0 upon A0 is equal to 0. Therefore, R0 is equal to 2A0. Therefore, option A is the correct answer. In an atom, an electron is moving with a speed of 600 meter per second with an accuracy of 0.005%. Certainty with which the position of the electron can be located is, where h is given Planck's constant and mass of electron is given. We know that delta x into delta p is equal to h upon 4 pi. Delta x into m into delta v, which is equal to h upon 4 pi. Therefore, delta v, that is change in velocity, is 600 into 0.005 divided by 100. On solving this, we get 0.03 as delta v. So delta x into 9.1 into 10 raised to minus 31, that is mass into velocity, is equal to 6.6 into 10 raised to minus 34 Planck's constant upon 4 pi. Therefore, delta x, that is uncertainty, which is equal to 6.6 into 10 raised to minus 34 divided by 4 into 3.14 into 9.1 into 0.03 into 10 raised to minus 31. On solving this, we get 1.92 into 10 raised to minus 3 meters. So option C is the correct answer. The measurement of the electron position is associated with an uncertainty in momentum which is equal to 1 into 10 raised to minus 18 gram per centimeter per second. The uncertainty in the electron velocity is the mass is given. So the momentum, change in momentum is 1 into 10 raised to minus 18. Change in velocity is equal to 1 into 10 raised to minus 18 divided by 9 into 10 raised to minus 28. On solving this, we get delta V is equal to 1 upon 9 into 10 raised to 10. On solving this, we get 0.11 into 10 raised to 10, which is equal to 1.1 into 10 raised to 9 centimeter per second. So this is the uncertainty of velocity. Option C is the correct answer. 200-gram golf ball is moving with a speed of 5 meter per hour. The associated wavelength is, where h is given, we have to find the wavelength of the order. So we know that lambda is equal to h upon mv. Substituting the values, h is 6.625 into 10 raised to minus 34. Mass is 0.2 kg into velocity is 5 meter per hour, so 60 into 60. On solving this, we get value of 2.4 into 10 raised to minus 30 meter. So the order is 10 raised to minus 30, option C. The kinetic energy of one electron is 2.8 into 10 raised to minus 13 joule. What is the de Broglie wavelength? We know that kinetic energy is half mv square. Here m is mass and k is kinetic energy, which is given. Kinetic energy is this much and mass of one electron is 9.1 into 10 raised to minus 31 kg. Therefore, we can find velocity as 2.8 into 10 raised to minus 31 is equal to half into 9.1 into 10 raised to minus 31 into v square. On solving this, v is equal to 0.784 into 10 raised to 9 meter per second. Since lambda is equal to h upon mv, lambda is equal to 6.6 into 10 raised to minus 34. Mass is 9.1 into 10 raised to minus 31 into velocity is 0.784 into 10 raised to 9. Therefore, wavelength or lambda is equal to 9.25 into 10 raised to minus 13 meter. Option A is the correct answer. The wavelength associated with an electron moving with velocity 10 raised to 8 centimeter per second is. So we have to find the wavelength associated. Lambda is equal to h upon mv. H is 6.6 into 10 raised to minus 34. Mass is 9.1 into 10 raised to minus 31 into 10 raised to 8 velocity, converting into meter per second. On solving this, we get 725 into 10 raised to minus 9, 0.725 meter, which on solving, shifting the point, we get 7.25 into 10 raised to 10 meter. So 7.25 into 725 angstrom unit. So option B is the correct answer. The de Broglie wavelength associated with a ball of mass 1 kg having kinetic energy 0.5 joule is. Lambda is equal to h upon root of 2 m e, where e is kinetic energy. Substituting the value 6.6 into 10 raised to minus 34 upon root of 2 into 1 into energy is 0.5. On solving this, we get 6.6 into 10 raised to minus 34. So option A is the correct answer. Many electrons have non-integral atomic mass because A, they have isotopes, B, their isotopes have non-integral masses, C, the isotopes have different masses, D. The constituent neutron, protons, and electron combine to give fractional mass. So the elements have non-integral atomic mass because they have isotopes with different masses. Isotopes with different mass. The average atomic mass is the weight mean of their present in nature. Like chlorine 35 and chlorine 37 are present in ratio 3 is to 1. So A is equal to 35 into 3 plus 37 into 1 divided by 4, which is equal to 35.5. So option A and C are correct answers. Which of the following have the same number of unpaired electrons in d orbitals? Chromium, manganese, and Fe3 plus have 5 unpaired electrons in d orbitals. Chromium 24 is equal to 3d5 4s1. Manganese 25 is 3d5 4s2. And iron Fe3 plus, which has atomic number 26, is 3d5 4s0. So each of these element have 5 unpaired electrons in the d orbital. So option A, B and C are correct answers. Pick out the isoelectronic structures from the following. Isoelectronic structures are the one which have same number of electrons. CH3 plus has 6 plus 3 minus 1 is equal to 8 electrons. H3O plus has 3 plus 8 minus 1 is equal to 10 electrons, and ammonia has 7 plus 3 is equal to 10 electrons. CH3 minus has 6 plus 3 plus 1 is equal to 10 electrons. So option D is the correct answer. Which of the following statements are correct? A. The electronic configuration of chromium is this. The magnetic quantum number may have a negative value. In silver, 23 electrons have spin of one type and 24 have opposite type. The oxidation state of nitrogen in HN3 is -3. Statement A, B, C, that is the oxidation state of nitrogen, is correct. Statement A, B, C are correct, and the oxidation state of nitrogen in HN3 is -1 by 3. 1 plus 3x is equal to 0. Therefore, 3x is equal to -1. Therefore, x is equal to -1 by 3. So, statement A, B, C are correct statements.